Imagine two particles on opposite ends of the universe. If you change something about one, the other instantly reacts, no matter the distance. This isn't science fiction. It's quantum entanglement, one of the strangest and most fascinating phenomena in physics. Even Albert Einstein himself was baffled, calling it spooky action at a distance. But what exactly is quantum entanglement? How does it work? And could it hold the key to breakthroughs in quantum computing and even interstellar communication? In this episode, we'll break it all down and uncover the mysteries of entanglement. What is quantum entanglement? To understand entanglement, let's start with the basics. In classical physics, objects are separate and independent. A ball rolling down a hill has nothing to do with a ball rolling down a different hill miles away. But in the quantum world, things work differently. When two quantum particles become entangled, their properties, such as spin, polarization, or state, become linked no matter how far apart they are. This means that if you measure one particle's state, the other particle's state will instantly adjust to match, even if they are on opposite sides of the galaxy. This defies everything we know about physics because the information seems to travel faster than light. Something that Einstein's theory of relativity says is impossible. So, what's going on here? Einstein versus quantum mechanics, the great debate. When quantum mechanics first emerged in the early 20th century, Einstein wasn't happy with it. He believed the universe followed strict, predictable laws, where everything had a defined state before being observed. But quantum mechanics suggested otherwise. Particles existed in a state of superposition until measured, and worse, they could be entangled in ways that defied logic. In 1935, Einstein, along with physicists Podolsky and Rosen, published a paper arguing that quantum mechanics must be incomplete. This became known as the EPR paradox, Einstein-Podolsky-Rosen paradox. They believed that something hidden, some hidden variables, must be explaining entanglement, rather than the particles mysteriously influencing each other across space. But in the 1960s, physicist John Bell proposed a groundbreaking experiment to test Einstein's theory. His results? Quantum entanglement was real, and there were no hidden variables. Einstein was wrong. Quantum mechanics was correct. How does entanglement actually work? The idea of entanglement sounds like magic, but it follows quantum rules that we can test and use in real-world applications. Here's how it works. Two particles are created in such a way that they become entangled. When we measure the state of one particle, like its spin, the other instantly takes on a correlated state. This happens instantly, no matter how far apart they are. But how does the second particle know what happened to the first one? That's the biggest mystery. Some scientists believe this hints at deeper layers of reality we don't yet understand, or even a potential hidden connection between space and time. Real-world applications of quantum entanglement. Entanglement isn't just a weird quantum quirk. It has real and revolutionary applications in technology and science. Quantum computing. Quantum computers use entangled particles, qubits, to process massive amounts of data at speeds impossible for classical computers. Quantum cryptography. Entanglement is being used to develop ultra-secure communication methods, making hacking nearly impossible. Teleportation. Scientists have already used entanglement to teleport information between particles across distances. While we're not teleporting people yet, this is a huge step toward faster-than-light data transfer. Future space communication. Some researchers believe that quantum entanglement could one day allow instant interstellar communication, a potential game-changer for deep space exploration. Does entanglement violate the speed of light? One of the biggest questions about entanglement is, does it allow faster-than-light communication? The answer is tricky. Yes, entangled particles react to each other instantly, but scientists argue that no actual information is traveling between them. So it doesn't technically break the speed of light limit. However, this is still a hot topic of debate in physics. If we ever figure out how to harness entanglement for communication, it could completely change our understanding of time, space, and reality itself. Quantum entanglement is more than just a strange phenomenon. It's a window into the fundamental nature of reality. Could entanglement be the key to future space travel, or even proof of hidden dimensions? The possibilities are endless. In our next episode, we'll tackle an even bigger mystery. Do parallel universes actually exist? Are there infinite versions of you living different lives? Don't miss it! Like, subscribe, and hit the bell to stay updated with our series, Quantum Physics and the Universe. Comment below. If you could send an instant message to another galaxy using entanglement, what would you say?